What is negative correlation in Python data analysis? Imagine you're tracking how things change over time. Sometimes, when one goes up, the other goes down. That's what we call negative correlation. It's a way to see if two variables tend to move in opposite directions. In data analysis with Python, negative correlation is measured using a number called a correlation coefficient. This number can range from -1 to +1. When the coefficient is close to -1, it means the variables have a strong inverse relationship. So, as one variable increases, the other decreases significantly. If the coefficient is near 0, it shows little to no linear relationship. And if it's close to +1, both variables tend to increase or decrease together. To find negative correlation in Python, you usually use libraries like Pandas, NumPy, and SciPy. With Pandas, you can create a data table called a data frame and use the core method. This method gives you a matrix showing the correlation between all pairs of variables. Negative numbers in this matrix tell you which pairs are negatively correlated. NumPy and SciPy also have functions to calculate correlation coefficients. For example, Pearson's correlation measures linear relationships, which is useful for detecting negative correlations. Spearman's rank correlation and Kendall's tau are other options that work well when data isn't perfectly linear or has outliers. Visual tools can make understanding negative correlation easier. Scatter plots are great because they show data points. If the points trend downward from left to right, that's a sign of negative correlation. Heatmaps of the correlation matrix, created with Seaborn, can also highlight negative relationships with color. Knowing about negative correlation helps in many areas. For instance, in finance, if two assets have a negative correlation, investing in both can reduce risk. In marketing, understanding how different factors oppose each other can guide better decisions. In summary, negative correlation in Python data analysis is about measuring and understanding how two variables tend to move in opposite ways. Using correlation coefficients and visualization tools, you can spot these inverse relationships clearly and use that knowledge to make smarter choices.